Okay everyone, so we're moving on to a new topic today. We're moving off sequences and onto straight line graphs. I am going to put up an extra video about sequences there because I had a couple of emails about the the sequence questions where it's with shapes rather than with a sequence. So if you want to go have a look at that, you can do. That'll be a different video, but that's completely optional. You don't have to. Just if you think you would benefit from having a look at it, feel free. So see it as like an extension. But it's not worth spending a full lesson on it because it's quite similar to some of the other questions. Right, but on to straight line graphs. So we have done some of this before, and you will have seen it back when we did inequalities and when we're plotting line graphs to work out which one works with inequalities. But if you're happy with it already, you can see this as a recap. You don't need to watch the video, you can just go and do the task if you're feeling confident already. If you're feeling like you'd benefit from watching the video, just a bit of a recap, yeah, stick around. Right, so firstly we've got some vertical and horizontal lines. So what is the equation of this line here, so the yellow one? So basically a line is just an equation. So the equation of a line is an equation that tells us the rule that fit all points on the line. So let's pick some points on the line and see if we can spot what the rule is. So this one, the coordinates would be 2, 3. This one, coordinates would be 2, 1. So here, 2, minus 2. What do all of these points have in common? So looking at the coordinates, they all have an x coordinate of 2. So the equation for this one would just be x equals 2. Quite straightforward. So when you've picked a few points on the line, you can see what they have in common, and that tells you the rule. So the vertical and the horizontal ones are a little bit more straightforward. So vertical ones, it's going to be x equals and then some number. So with this one, it's x equals 2. The other way you can see that is you see which axis is it that it's cutting through. So it's cutting through this one here. So it cuts through the x-axis, and it's cutting through at 2. So that tells us x, because it's the x-axis, equals 2. So similar kind of idea. We've got another line here. I'll just put on our x and our y-axis. So we've got our line. Let's pick some points to see if we can spot the rule. So that is 2, 1. We've got minus 2, 1. That is 5, 1. Sure, some of you have spotted the rule here. We've got 1 as our y coordinate for every point on that. And so any point you pick on this line will have the y coordinate 1. So we just write y equals 1 as our equation of the line here, y equals 1. Again, similar idea to what I did with the shortcut before. We can also look which axis does it cut and at what point. So it's cutting through the y-axis at 1. So that tells us y equals 1. So fairly straightforward. If you've got a vertical or horizontal one, they're a bit easier to do. It's just going to be either x equals or y equals and then a number. Right, so basically with straight line equations, the equation just tells you the rule of all of the points that fit on the line. So what I'd like to do now is with these, if you want to pause the video and have a look, you can do, see if you can do this already. If you want to just watch me go through it, that's fine as well. So basically what we've got here, we've got the equations of the lines. This basically tells us a rule that links the x coordinate and the y coordinate. In this case, the first one, there's no x coordinate, so that's just going to be a horizontal line going through the y-axis at 3. So what we're looking for is points that have got a y coordinate 3 for this column, because it's y equals 3. So let's look, so 2, 0. Well, looking at the y coordinate, it's not 3, so that tells me it's not on the line. So next one, look at the y coordinate, so that is 3. So this one is on the line. And last one, again it's y equals 3, so we look at the y coordinate, 7/4, so that one is not. Okay, so a little bit more complicated now with this next one. We've got x plus y equals 2. Basically we just need to see if the x coordinate plus the y coordinate equals 2. If it does, it's fine, it's on the line. If If it doesn't, it's not on the line. So let's check this. So 2, 0. So 2 add 0 is 2. So that one would be on the line. 2, 0 is on that line. Let's have a look at this one. So minus 1, 3. So minus 1 add 3 gives us 2. So we'd have minus 1 plus 3 equals 2. So that one is on the line because it's equal to 2. And last one, we've got 1 quarter and 7 quarters. 7 quarters. So adding those together, that gives us 8 quarters, which is 2. So that one would also be on the line. It's just a bit nastier because it's some fractions. But all three of those are on the line. Okay, and last one, so this is y equals 3x plus 1. So we're going to have to substitute in the x and the y and see if it works. So let's substitute in y equals 0 and x equals 2. So we've got 0 equals 3 times 2. I'll put that in brackets to make it clear we're doing that first. Plus 1. So we end up with 0 equals 7. Well, that's not true, so that one doesn't work. So that one would not be on the line because it doesn't follow the rule. Right, so we've got a y coordinate of 3 for this one. So we've got y equals 3 times minus 1 and then plus 1. So we've got 3 equals, so it'd be minus 3 plus 1, so minus 2. Again, doesn't fit it, so that one would not be on the line. And last one, so we've got 7 over 4 equals 3. That's 1 over 4 plus 1. So where I've got this plus 1 here, I'm just going to change that to 4 over 4. So 4 quarters is just 1. It's just a different way of looking at it. I'll make this next step a bit easier. So 7 over 4 equals, so that's 3 over 4 plus 4 over 4. So adding 3 quarters and 4 quarters, that does give me 7 quarters, so that one is on the line. Again, this last one's just a bit nastier to deal with because it's fractions, but same concept. You're just substituting in x and y, seeing if it works. Okay, we've seen one like this already. I'll just quickly go over this. So you see it's cutting through the y-axis at minus 1. So that one would be y equals minus 1. I thought I'd got rid of this slide. Right, a little bit trickier though. So this one, let's pick some points and see if we can spot the pattern here. So we've got a point here, minus 1, minus 1. Point here, 2, 2. So I'm not picking any points in particular, just random points on the line. I'm tending to pick ones that are on the grid lines because they're easier to read the coordinates, but you could pick any and it would be the same rule. Okay, I'm sure some of you are spotting the rule so far. So minus 2, minus 2, minus 1, minus 1, 2, 2, 3, 3. What do we notice? We notice that the x coordinate is always the same as the y. So, I mean, it's down here anyway. So we'd write for this one, y equals x. You could have x equals y. They're both valid. We tend to go for this form though, the y equals x. So it's not very neat. We tend to go for the top one, y equals x. That is because when you go higher in GCSE, y equals x gives us a better form for sort of doing the more complicated questions. It tends to be the form you're given the lines in, so it's less effort rearranging. So we tend to go for this top form, even though this second one's just as valid. So diagonal line, y equals x, would look like this one. Okay, we'll just have a look at this one as well. A few more of these. So we've got minus 1, 1, 0, 0, 2, minus 2, 4, minus 4. This one's a little bit less obvious, but I'm sure some of you will be able to work it out. So I'm sure some of you have noticed the numbers in them, the x and the y coordinate is the same number, but one of them is negative, one of them is positive. So for this one we'd write y equals minus x. So whatever x is, y is the minus version of it. Or you could also write x equals minus y. It would be equivalent, but again, like I said with the last one, we tend to go for this form because, again, this works better when we start using other line equations with it. We tend to go for the y equals rather than the x equals. So looks similar to the one we just did going upwards, but now it's sloping downwards instead. when we look at gradient next lesson, you'll sort of get a better understanding of that. Okay, so now what we're going to do is use the axis to sketch the line with the equation y equals 2x minus 1. So there's more than one way you can do this. I'm sure some of you know how to sketch a line already. I'm going to show a slightly different method of what we're doing today that'll work better with what we're doing today, and then next lesson we'll be looking at using gradients and y-intercepts. But if you've got a method that you know already, feel free to use that when you're working through this one. So y equals 2x minus 1. So what I'm going to do is just pick 2 points on the line. And I'm going to do that by picking two x values. So x equals, let's pick nice easy ones. Let's do x equals 0 and x equals 1. So when x equals 0, I'm going to substitute in x equals 0 to this. So I've got y equals, and 2 times 0, because I've said x is 0, so y equals 2x, y equals 2 times 0 minus 1. So 2 times 0 is just 0, so we've got 0 minus 1, so we've got y equals minus 1. So when x equals 0, y equals minus 1, so that means it's going to hit here. So this is the coordinate 0 minus 1. So let's do the same with x equals 1 to see what we get. So we've got y equals, so we've got 2x, so that's 2 times 1, and minus 1. So 2 times 1 is 2, minus 1 gives us 1. So when x is 1, y is 1 as well. So I'll go through about there. So I think, so you can see I've not quite drawn that accurately, but it goes through those 2 points. The slides have done different ones. They've picked down here and up here. Can do that. If you do them further apart, chances are you'll get a slightly more accurate line, but you can pick any 2 points. I just picked 2 that would give, that are easy to substitute in. So 0 is quite often a good one because then it gets rid of this term, because something times 0 gives 0. But whatever works best for you. Okay, so with this example, we've got to work out which values of x and y fit the line equation. So with this, we can see we're given a value for x here. We need to work out the corresponding y coordinate. So the way we do that is we're going to substitute in our x coordinate. So we've got x equals minus 2. We need to work out what y is. So we've got x plus 2y equals 1. Let's rearrange this to work out what y is. So we'll substitute in x equals minus 2. So wherever we have an x, we're going to change it to a minus 2. So we've got minus 2 plus 2y equals 1. So I just put sub x there to substitute x. And now we just need to work out what y is. So let's add 2 to both sides. So that gives us 2y equals 3. And then from there, we're going to divide by 2 to get y equals 3 over 2. So don't worry if you get a fractional answer. You can do with these ones. It's just a bit more of a faff to draw on your diagram, but you can get it. With the half ones, they're a bit more straightforward, but you can get them when they're a quarter, which are a bit less accurate. If you do get that and you're doing a test, it might be worth trying a different coordinate, see if you can get a whole number one, because it's much easier to plot if they both hit grid lines. So with this one, for example, they've got minus 1, 1. If you got that one, it's 2 that are on a grid line, so it'd be easy to draw. Right, so let's have a go at this one. So we've got x equals 0 now. So we're going to be substituting in 0. So we've got x plus 2y equals 1 still. That's our equation of the line. So we know that x equals 0. So sub x equals 0. So 0 plus 2y equals 1. So it tells us 2y equals 1. So I'm dividing by 2. That just tells us y equals 1/2. So I've got a half there. And then a couple more. So if you're feeling confident with this, feel free to skip ahead, you don't have to stick around. So x equals 1. So we've got x plus 2y equals 1. We know that x is 1, so sub x equals 1. So 1 plus 2y equals 1. Minus 1 from both sides. So 2y equals 0. y equals 0. So that tells us 0 there. So another one there, both grid lines. That'd be a nice one to do in drawing. Last one, x equals 2. And we've got our equation x plus 2y equals 1. So each time just using the equation of the line to work out the y coordinate. So we've got 2 plus 2y equals 1. So it's minus 2 from both sides because we're trying to get y on its own. So we've got 2y equals minus 1. Divide by 2 gives us y equals minus a half. So we've got all of our x and y coordinates now, and you could plot them now, or you could just put any two and then connect them up, and because it's a straight line graph you would get the same straight line, but it should go through all of those points. Okay, so what I'd like you to do now is go have a go at the worksheet, see how you get on with it. You may be fairly confident with the earlier ones but struggle with the later ones. If that is the case, I'm going to be going through the answers to the later ones. On the sheet as well there are some killer questions which have got the skull and crossbones. Those are significantly beyond what you need at the moment, so if you are struggling with those, don't worry too much, that is way beyond. But if you want to have a go at them, if you're feeling confident with the other stuff, please do have a go. They're really challenging questions, but if you manage to jump, very satisfying. So pause the video now and go have a go at those ones on the sheet. If you can't do the killer ones, as I say, don't worry, but it might be worth watching the video because it is tough maths and it'll be good to have a look at. Okay, so this first one, we've got x plus y equals 2. So what we're going to do is pick 2 points on the line and join them up. Or if you're feeling confident with doing it the other way and using the gradient and intercept, you would have to rearrange, but either way works. So it should look like this. So it passes through the y-axis at 2 and the x-axis at 2 as well. So if you've done your x and y-axis the same scale, it'll look slightly different, it'll look a bit steeper, but this one it's scaled up in 2s on the y-axis and 1s in the x-axis, so it looks a bit different. So it passes through the y-axis at 2 and the x-axis at 2. This one should pass through the x-axis at 2 and the y-axis at 1. So again, looking out for the scale. Okay, so 4x minus 2 should look like this. So this one's sloping upwards, so it should pass through the y-axis at minus 2 and the x-axis at 1/2. So depending on how you've done your scale, it might look a bit different to this. Okay, question 4, so filling in the table. So we've got our values there, 6, 1.5 and 0. So if you've got it as a fraction, it'll be 3/2 for the 1. Your graph should look like this. So when you've got your table, it's fairly easy just plotting it, you just do the coordinates. Okay, question 5, we're saying are they on the line or not, so you're substituting in the coordinates into the equation of the line to check if they work. So I'll just reveal these. Okay, well done if you managed to get all of those. Okay, so with this one, you need to work out whether the coordinate is below, on or above the line. So there's a couple of ways you can do this. You can either sketch the line and then just put the coordinate and see if it's above, below or on. But the hint, find out what y is on the line for a given x, that's I think the fastest way to do it. So what you would do is look at the coordinate, so for this first one 3, substitute that into the equation, so you've got 3 times x, so 3 times 3 plus 4, so the line would pass through 3, 13, so that would be above 311, so this coordinate would be below the line. So what you'd be working out is what coordinate it goes through there, so that one would be below the line, because the line passes through 313, this one the coordinate is 311, so that is below. So this next one, x plus y equals 5, so you've got an x coordinate of 7, so we substitute in 7, so you've got 7 plus y equals 5, so if we rearrange that, that tells us y is minus 2. So the coordinate here is 7 minus 2, so we see that that is the same, so that one would be on the line. So similar idea for these last two as well. substituting in, seeing what the y coordinate is, and then seeing if the coordinate that you're given is above or below that. Okay, so this is our first of the killer questions, so this is quite a tough one. I'm going to work through this one here. So we've got ax plus by equals c. So it says the x value of some point is d. What is the full coordinate of the point in terms of a, b, c and d? So we're told the x coordinate is d, so we know it's going to look like that already. What we need to do is substitute in that and rearrange for y. So we've got a times d plus by equals c. So it's going to be a very algebraic question, this one, because we've got just 5 letters, no numbers at all. We're trying to rearrange it to get a y, because we want to know what the y coordinate is when x is d. So we're going to start off with minus ad from both sides. So we've got by equals c minus ad. We've got to do it to both sides actually, so I should have done the arrow there as well. So we've got by equals c minus ad, and to get just y on its own, we need to divide by b. So we end up with y equals, got to do that to both sides, so we've got c minus ad all over b. So quite a tough algebra one there. So our coordinate then, our y coordinate is c minus ad all over b. Okay, so for this last one, a diagram would be quite helpful, so if you wanted to do that, that would certainly help. I'll just do a quick sketch of what it'll look like. So it'll be something like, so you've got your axes, it's going to be a line sloping downwards. So what it's asking us is, what is the area of the region enclosed between the line with this equation, the x-axis and the y-axis? So it's saying what is the area of this shape here. So we're trying to work that out. So we can see straight off the bat it's a triangle, and more specifically, when you've got axes like this, they meet at a right angle. So it's a right angle triangle. To work out the area of this, it's going to be a half base times height. So we need to work out what the base is and what the height is. And to work them out, so the base goes from 0 to the point where it hits the x-axis. The height, similar idea, it goes from 0 to the point where it hits the y-axis. So what we need to do now is work out where does the line hit the x-axis and where does it hit the y-axis. So I'll just do my sketch a little bit bigger. Not very neat. So where it hits the x-axis, what is the y-axis here? Sorry, what is the y value here? So on the x-axis, the y value is always 0. So y value is 0, we're going to substitute that in. So if we've got 2x plus 7y plus 3, we're going to sub in y equals 0. So that is for the x-axis. So sub y equals 0, so we've got 2x equals 3. So divide by 2. That tells us x equals 3 over 2. Okay, we also need to find the y-intercept, so where it hits the y-axis. So on the y-axis, the x value is already 0. So we've got 2x plus 7y equals 3. And on the y-axis, the x value is already 0. So we're going to sub x equals 0. So we end up with 7y equals 3. So divide by 7, both sides, y equals 3 over 7. Okay, so we've done a lot of the hard work, so we've got now a triangle. It looks like this, it's right angle. It's got a base of 3 over 2. It's got a height of 3 over 7. So the area is a half times base, which is 3 over 2, times height, which is 3 over 7. So we've got half base times height, and then we work it out, and that should give us the area. So we've got three fractions all times together, so times the numerators times the denominators. So we've got 9 on the top over 28. And there's no common factors there, so we just leave it as 9 over 28. If you wanted it as a decimal, that would be fine as well.